Here we're given some function of x that consists of a sine and a cosine, and we're asked to write it in the so-called R form that consists only of a sine. And helpfully, they've already found the value of alpha for us. They've given us the phase shift. So all we need to do is find R. So there's several ways of doing it. The long way, which is the safest way, is to write this using the sum formula, so sine A plus B. So sine x plus 30 is sine x cosine 30 plus cosine x sine 30. And then because you've got the R there, you need to write the R there. And then if you look at each of these terms, this sine corresponds to that sine. So therefore, you could say that the R cosine 30 must equal 18. And from that, because cosine 30 is root 3 over 2, you can rearrange to find R. So that's your value of R. But you need to check the other term. So if you look at this term, it needs to match. So you need to make sure that if this cosine is this cosine, then root 6 must be R times sine 30. And if you write that out and sine 30 is just half, you end up with that. And because these two match, then it means that's the correct value of R. Now, a shorter way is simply to take this and that, square them, and then square root the sum. That will have given you R, but I suppose the longer and safer way is to make sure that this is correct, because it could be that that angle was incorrect because we didn't find it. We had to assume that it was correct. So either way is fine. The easy way is to take these two coefficients, square them, add them, square root. That'll give you the value of R. Okay, the question then goes on. So the last thing you need to do, now you found R, is to write f of x in this form with R replaced by the value you found. And 30 you already know. So the question goes on to say, solve an equation that looks a little bit like that, and that this bit is f of x. So this is that. And when they say hence, they mean using what you've just found. And what we've found is that we can replace f of x with that. So we can take this and replace it with this. So we can take that and replace it in the denominator. So now it looks slightly better. Instead of having sine x, cosine x, and x plus 30, now we have everything in terms of x plus 30. We have an x plus 30 here and an x plus 30 here. It still doesn't look very nice because we have a cotan squared and a sine. So we need somehow either to convert this into a sine or convert sine into a cotan. So we end up with some kind of a quadratic. Now cotan is cosine over sine. That probably won't help much. But if you realize that, so I can rewrite this as a coefficient multiplied by a 1 over sine. And if you realize that 1 over sine is just cosec. That's the definition of 1 over sine, or the definition of cosecant. So cosecant theta is 1 over sine theta. So when you see 1 over sine, you can replace it with cosecant. And although cosecant is still not cotangent, we're almost there. Because if you start from the identity that says sine squared plus cosine squared equals 1, and you divide everything by sine squared over sine squared will give you 1. Cosine squared over sine squared will give you cotangent squared, and 1 over sine squared will give you cosecant squared. And that's a relationship between cotan and cosecant. Cotan and cosecant. So I can rearrange to find cotangent squared. So now I know cotangent squared is cosecant squared minus 1. And I think I forgot the theta here and here. So now we can take this cosecant squared minus 1 and replace the cotangent. So the cotangent becomes cosecant minus 1. So it's just a case of substitution. And that's good because now we have a quadratic, because you've got cosecant and cosecant squared and a constant, nothing else. So now it's really good. The only thing is, what we need is a 0 here. So if you bring the 2 to the left, you end up with a 0. And you've got cosecant and cosecant squared. So if you say something like, let y equals cosecant x plus 30, you then can say that this is just y, and this is y squared. You don't have to do this, but it looks nicer because now you have a quadratic that's very clearly quadratic. You won't get confused by the plus 30. So now we can solve a quadratic using the quadratic formula. So if you realize that if you rearrange this so you have y squared first and this next, you can see that the coefficient of y squared is a, the coefficient of y is b, and the constant is c. And you can put those into the quadratic formula and stick that in your calculator. You'll get 2 values for y. Now that is not the end of the question, because y is actually just cosecant x plus 30. Remember, we said y is cosecant x plus 30. So we need to replace y with cosecant x plus 30. So there's still quite a long way to go. We're trying to find x, so there's quite a bit of manipulation to rearrange this. So we write cosecant x plus 30 equals 1.63, and then again for 1.84. Now cosecant is 1 over sine, so you replace the cosecant with 1 over sine. And then somehow you need to rearrange this. You can either multiply both sides by sine, or you can cross multiply, or you can invert both sides or flip both sides. So sine becomes 1 over 1.63. And then to get rid of the sine, you need a sine inverse for both sides. The sine inverse will cancel the sine, and you'll find sine inverse of that, and the same here. You need sine inverse for 1 over minus 1.84. So that will give you let's just hide this for a second because it's confusing. So that will give you x1 plus 30 and x2 plus 30. So directly from the calculator, make sure your calculator's in degrees, you should get these two values. Now don't rush to move the 30. Forget that for now. Move on to find the next few values. So I'm going to cover that for a second. So the next thing you do is say if that's x1 plus 30 and that's x2 plus 30, you need to find the next set, x3 and x4. And you do that, because it's a sign, you subtract the number you just found from 180. So that'll give you x3 plus 30 and x4 plus 30. So now we found all four. So 1, 2, 3, 4. Now what we need to do is subtract 30. So each of these, you subtract 30 to find the actual value. So that is 7.8. That's fine because it's within the range we're given. We're told that x has to be between 0 and 360. So 7.8 is okay. If you add 30 to minus 32, you get a negative, so that is not within the range, but you can add 360 to that. You're allowed to add 360 to bring it within the range. So that now is okay. Subtract 30 from 142, that's within your range, and subtract 30 from 212, and that's within your range. So now you have your four solutions, 1, 2, 3, 4. You can check, you can take any of these solutions and put it back into the original equation. You can put x here, here, and here, and you should get 2. So that's an easy way to check. Okay, so you can put this in your calculator. Obviously, you can't put cotan, but you can put 1 over tan x plus 30 in your calculator. And you should get 2 or something very, very close to 2. So that's how you would answer this question. So when they say hence, it means use what you've just found. And we also had to use another identity here. And there was a quadratic. So there's quite a lot of work in this question. I hope you found that helpful.